VLSos here. This is a video lesson on slope as an angle. Slope is an essential concept in mathematics. It is very meaningful to real life, real world contextual problems. Slope also has connections and concepts in all the levels of mathematics, especially higher mathematics like calculus. Slope can be defined very simply, though there's a lot that we can do with it and a lot of ways that we can study it. Slope is the measure of incline of a line. Lines in mathematics are perfectly straight. They go in two directions. Lines have slope. We can measure the slope of a line. What we're going to do here is we're going to compare slopes of lines and use descriptive language and talk about the line's slope with the idea of an angle. We have 4 different lines here. I'm going to draw another one. This line is a little bit special because it is horizontal. Or we could say flat, perfectly flat. This horizontal line does not incline. It doesn't go up and it doesn't go down. A horizontal line has a slope of 0. The measure of incline of a flat line is nothing. It's 0. But 0 is an important value. These 4 lines here have a non-zero slope. This one has a small positive slope. And we can compare it to this line and think of it as having a large positive slope. These lines slope up. Up is the positive direction. If we were going to consider the slope as an angle, then we would compare the slope of this line or the direction of this line with a horizontal line that has a slope of 0. The slope of this line is the angle between it and a horizontal. We could have a protractor to measure it. We could estimate it maybe 18 degrees. Positive 18 degrees, the slope is going up. The large positive slope line, we would also compare the slope of the line with a horizontal, which is perfectly flat. And we could estimate the angle of this to be maybe something like 75 degrees. These lines have negative slopes. They're sloped downwards. We could describe this as a small negative slope. And this here to be a large negative slope. This slope is negative because the angle compared with or between horizontal and the line would be a negative measure. We'd approximate it maybe negative 15 degrees, a small negative slope. We could say this line is in decline because you have to go down. The large negative sloped line we would compare with a horizontal. The angle between them would be something large like 80 degrees, but negative. Some real-world examples of things that have these slopes. We could consider maybe the small positive slope to be like a hill that we could walk up. A small negative slope, we could think of a ski slope. And when we ski, slope is right there in the word. Something that has a large positive slope, maybe a mountain. Imagine looking at the bottom, being at the bottom and looking up a steep cliff. And a large negative slope we could call a cliff. Imagine standing on the edge and looking over a cliff that goes down. If we're considering something like a hill to have slope, it might be a little bit odd to think of a hill as sloping up instead of down, because we could be standing on a hill and think, well, if I travel in one direction, I'll be going down. And if I travel in the other direction, I'd be going up. So why would we call this line to have a small positive slope as one that is sloped up? Why isn't it sloped in both directions, depending on which direction you go? And that's because we have standardized what we mean as the direction of movement. We consider movement that comes from the left and goes in the direction to the right as forward movement, as positive movement in mathematics or on a graph. Standardizing this as what we mean by moving in the positive direction helps us to distinguish and know for certain what we mean by up and down. Imagine that we're standing on this line as if it was a hill. If we're going to move in the positive direction, it means that we need to be going to the right. The direction of motion that is meaningful in the positive direction is to be moving on this line to the right. And as we go to the right, we go up, which is why we say a line like this goes up. As we move to the right, we must also move up. If we're on this line here, anywhere on the line, and we move to the right in the positive direction, we also have to move up to remain on the line. So the direction of this line is up, has a positive slope. The lines that we call negative, which are sloped down, means that if we're anywhere on the line and we move to the right, which is the positive direction, we also have to be moving down to stay on the line. There's one other line that's kind of special, a vertical line. And just like we call a horizontal line flat, we could call a vertical line upright. Well, let's consider the slope of a vertical line. Let's also include this idea about a vertical line going up or down by moving to the right. If we're on a vertical line and we move to the right, we cannot be on the vertical line. If we're on a vertical line and we move any to the left, we'll also step off the line. If we're on a vertical line, we can't move to the left or right. Vertical line's orientation is such that if we're going to remain on the line, we can only move up and only move down. This idea of the slope requires moving to the right. The idea of the slope means it is literally the measure of how much we are going to go up or down if we move to the right. If we can't move to the right on a vertical line, then a vertical line can't have a slope. It doesn't have a slope of 0. That's the slope of a horizontal line. The slope of a vertical line is undefined. We can't have the concept of the slope with a vertical line because we can't measure how much we're going to go up or down as we go to the right.